This paper introduces a method that significantly enhances large language model, or LLM in short, performance by scaling up the number of agents using a sampling and voting approach. It shows a direct correlation between agent count and task performance improvement, making LLMs more efficient in complex problem solving without needing complex frameworks. The problem which this paper is trying to solve is that many LLMs face challenges in processing complex tasks due to limitation in existing enhancement methods like chain of thought pipelines and multi-agent collaboration framework. These methods are intricate and not always effective across different tasks, leading to inaccuracies and inefficiencies in model outputs. If you don't know what chain of thought pipeline is, then let me give you a very quick overview. Chain of thought refers to an approach where the model or LLM generates intermediate steps or reasoning paths when solving complex problems or answering questions. This method mimics human like reasoning processes, making the model's output more interpretable and sometimes improving the accuracy of the answers by breaking down the problem into smaller, manageable parts. So, that is what roughly chain of thought is. Coming back to what we are dealing with here, this new model is not only simple to follow but easy to implement too, though it requires a bit more resources. So this solution, which says that more agent is all you need, tackles this issue by implementing a straightforward method of adding more instantiated agents and applying a sampling and voting technique. They have also done some benchmarking. So if you go through their paper, they have shown that it performs really well on a lot of other models and benchmarks. This approach is complementary to existing method, allowing for combined use for further performance gains. So this research paper also explored task difficulty dimensions to optimize agent scaling effectively. And if you go through these benchmarks for when it comes to LLM performance, especially in tasks with varying difficulty levels, it really performs well. The performance gains are more pronounced with higher task complexity and longer reasoning steps, which indicates a scalable and cost effective way to boost LLM capabilities without the need for complex enhancement. That, and they also have a lot of other future work which is in the pipeline, because simply adding more instantiated LLM agent is what really needed to obtain a better LLM performance in processing complex tasks without bothering complicated method, as I mentioned, chain of thought pipelines and a lot of other stuff which is right now being used by various companies. Now, that they have also observed that the performance gains are influenced by the difficulty of task, as I mentioned. So that is why they have isolated and analyzed three dimensions of task difficulty: the inherent difficulty, the length of reasoning steps, and the prior probability of a correct answer. Now, based on these three properties, they have also developed ways to boost the effectiveness of more agents. I will also make a hands-on video once I have my hands on bit of a beefy system to show you how it works, because they have released this code a bit which can be used with OpenAI. The instructions of implementing are quite vague here, as I mean there's no step-by-step instruction or anything like that. They have these setting of API keys, they have shared some of the data set. So but let me try to run it. I think I would need to run this reasoning and generation task, and if my GPU is able to sustain it, I'll create another video to show you how exactly it works in practice. I'll drop the link to this paper in video's description too, so let me know your thoughts. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network, as that helps a lot. Thanks for watching.